Hello everybody, this is Paul Daniels here, and today I'm going to be doing a demonstration of the OpenFlex board viewer, which is a fork from the original OpenBoardView, originally written by Chlorodite several months ago. Now the OpenFlex is a feature enhanced version. It will be merged back into the OpenBoardView eventually, but for now, if you want the advanced features, it's the OpenFlex board viewer that you want to download and use. So we'll get started straight away. First we're going to load up a file, since that's pretty much where everything happens. And one of my favorite ones is the 2936B, because that was one of the first boards that I did, thanks to Lewis Rossman's videos, which I'm sure you all know about. Okay, board is loaded. We're using the light theme at the moment. There is a dark theme as well, which I'll show, and you can switch between the two of them. You can adjust the colors. It really is up to your personal taste. I've spent quite a few hours trying to pick some decent sort of colors, but obviously everybody's going to be a little bit different. What we'll just go through the menus here. Opposite file menu, open if you want to pick up a new file. What we have all here is a history of existing files that have been loaded. Most of these are ones I've either been testing or trying to fix myself. The next menu item is a partnet search, which can either be activated by Control F or for Unix people such as myself, just a / key. Then there's program preferences. We'll go into that. You can set the startup window size here. I like 1600, 900, but it's easy enough to go any size you like. The font size 20, that's fairly arbitrary. The screen DPI 100 here. I'm just using a normal 24-inch 1920 by 1200 screen. If you've got a 4K screen, you probably want to set this to 200 or 300. It will make sure that the sizes of the scroll bars and the text is proportionally increased based on your DPI. So yeah, if you've got one of the new high resolution screens, you might want to increase that, make things a little more readable. The ball field spacing set at 3 at the moment. That's the pinstriping spacing. You'll see that in the background here, and you can increase it. Looks a little bit too sort of open at that point. If you want a complete solid fill, just set that to 1. All these zoom modifiers, they refer to how much the mouse and keyboard zooms in and out, likewise the panning. The important thing to bring up here is this flip mode. It determines how the board is flipped when you click the center mouse button. Now initially it used to be the viewport, which would mean the board would be flipped vertically within the viewport itself. So you can see in the background here we've got the full board. If you hit flip, it would still fit in the whole screen and just be the other side. But what we found is now using a mouse version is it will flip it around wherever your mouse is pointing on the board, which is extremely useful if you want to see what is on the other side of the board. We'll get to see that in action a little bit later. Annotation features, don't really need to worry about too much about that. Pin select masks, we don't really use those anymore. These are all old features that I was trying out, but I've left them in there in case people want to play around with them. The center zoom search results, that just makes it so that the screen will be zoomed in to encompass whatever was found with the search results. That way, if it's only 1 or 2 pins in some obscure corner of the board, you'll get to go straight to it rather than searching around. The info panel is this here on the right. It's a fairly new feature that's only just come about, and we'll have a look at that a bit further later. If you don't want it there, you can just turn it off. The netwebs, again, we'll see that in a little bit. Now we have here some options for slow CPUs. If you click that, it will drop out certain features just to try and get things a bit faster. Fill parts, that's referring to do you fill in the parts on the board with another color. Fill board, that's obviously referring to this pinstriping that you can see. The FZ key, that's just for decoding FZ boards. color preferences. This is where you can probably spend a lot of time achieving, well, who knows what. All these colors have been picked over the course of a couple of hours, and they seem to work well enough for me, but obviously everybody's going to have different tastes. There are two base themes. We've got the light, which is what's already loaded, and we can switch over to the dark, and it's fairly reminiscent of what the original OpenBoardView was. So if you like that style more, well, it's easy enough to switch over. And we go back. I do prefer the light myself. There we go. Alright, views. This was more legacy stuff, so if you wanted to perform various actions you could do it through the menu, but the key accelerators are in there, such as here. I can just use those instead rather than coming up into the view menu all the time. The show FPS, that's actually for frames per second. That was more of a debugging thing, but again we left it in there. Show position, that's the board position. You can see that down here. It's useful for some people, but once again it's more of a legacy thing. And let's see, right, there. Help, the controls, it gives you a rundown of what does what. This tends to not change too many times, but every now and then there will be a bit of a shuffle around, but hopefully we've got it settled down for now. In the future we're hoping that we'll actually have programmable keyboard controls, so you won't actually be locked into a fixed set anymore. About, this is simply the license details and the copyright details of the various people involved. As well up here we've got the version. You can see this is build R573. It's got a tag of release 7.2, and it was only done a couple of days ago, as well as the website for the OpenBoardView, of course. Alright, let's get into, obviously the first thing you can see is zooming is easy enough. You just mouse scroll wheel up, mouse scroll wheel down, zooms in. Left click and drag, moves the board around. You can also use the arrow keys on the keyboard, moves it around if you want more precision. If you want finer control, you can hit the control key when you move around, and it reduces the step. You can rotate the board. There's many options you can do for this. You can either come up here to the tablet controls, and let's rotate left, or rotate anti-clockwise, rotate right, and we get back to there. These here for the zoom. This is a large zoom out, zoom in, and the finer step, zoom out, zoom in. Again, these are actually more for tablet users, but it's useful as well if you just don't want to use the keyboard and just get lazy. Now if you've lost the board for some reason, it's gone off the edge of the screen, let's just demonstrate that. Push it over there and you can't find the board anymore and you want to get it back, you can either press this here, the middle button on the numeric pad, or the letter X. And if I actually hit the letter X, not something else, there we go, it's back in the screen. And you can readjust the size of this info panel just by hovering over until it brings up this grey bar, left clicking and adjusting to what size you want there. Okay, recenter that again. Now, one thing some people may notice is that even though we're trying to detail the outlines of these connectors, like this, I think this is a speaker connector, is it? Microphone, right. And it doesn't always come out quite right. So like here, this is a little bit wonky relative to what it should be. If we zoom in down here, here we are, this one shows it up. See, the angle is not exactly perfect. It's because it's actually using an algorithm to try and find the minimum bounding box around the pins for the part, and it's not always orthogonal. For board files, these BRD files, there isn't any orientation information in there, so instead it just has to work it out or take a good guess at it. For FZ files, they do have orientation information in their data set, We haven't quite yet using that, but it's something that will be added in the future. So it's interesting to point out that drawing the parts at the right angles, such as these 45-degree parts here, was the first feature that made me start to write the OpenFlex board view variant from the OpenBoardView. And like so many things, it went way out of control, and now we've ended up with the project as it is. Okay, I'll better list up some of the variances in the colors here. You probably can see that some pins are darker than others, some are just different. What it is if you've got a ground pin, it picks the darker color there. This is something you can adjust in the settings for the colors. A normal pin is a slightly lighter blue color. A disconnected pin or unconnected, the grey pins. And as you've probably guessed, these are test pins, which are filled in with something close to a gold color, so it's moderately representative of what really is going on. Alright, let's have a go with the next step, which is search for something. Now, along with the theme of what was done first in all of this, my first board was a one-wire failure problem. So on this particular board, we got U6901, and there we go. I got lazy, didn't type it, just press enter, and there we go. It was centered straight onto the U6901. And let's see, sitting right next to the SMC, and with this particular board there's a fan back here and it blows all the liquid straight up over here, and I've had two of them now. One of them went over the SMC, the other one just missed it. Alright, now when a part is selected, you see it appears over here in the info panel. The info panel shows up of the pins and the various networks that are on them. Now, there's two buttons for each part that are in the info panel. One of them is just the part name. You click on that, it will center the part to the screen. But also, if you're way out here, excuse me, if you hit the Z, it will center and zoom it. So there you are. So you can get straight to the point. Now, if you select one of the networks on these pins, it will then pick every other part on that network. So you can see we've got 5 parts selected, which includes the SMC in this case. And you can just scroll down here. You see all the you see all the parts. And if you want to go to a specific part, just once again click on it. And that's taken me to the other side. And you can see here all the pins are showing up. If you hover over the pins, they'll show you the part name, the pin number, and the network that it's on. Now these lines that you can see radiating out from the point, they're part of the NetWeb feature. If you don't want them there, you can just turn off the NetWeb feature up here. As you can see, it's all gone, but to be honest, I find it very useful. Particularly when you're trying to find out where something goes on the other side of the board. You come here and we've got these light blue traces, which means it's on the other side. Put our mouse there, we middle click, and straight away it shows the other side of the board, and we can see that was going to U6901. Very quick, easy way of getting around things when you're trying to track down what's going on. Thankfully in this case it wasn't the SMC that was dud on my board. It was 6901, just happened to have been dead, needed replacing, and away it went after that. Alrighty, what else have we got to do? Well, as you can see, the board fill shows up very distinctly here. Now if you can turn that off, just to give you an idea. Okay, no board fill now, and we're back to the older, simpler style. It does increase the frame rate without the board fill because it's fairly computationally heavy to compute that fill. So if you do have a slower machine, you can turn it off and it'll give you a few more frames per second. Personally, I find it nice to know where the board is. It just gives it that sort of more realistic appearance. Alright, what else can we do here? Oh, annotations, that's right. This was a feature that I put in thinking it would be quite useful, but to be honest, in all the work I've been doing, it hasn't come up with that as often as I thought. But obviously once you put a feature in and got it working, you may as well just leave it in there, just in case someone else does want it. So let's find our 6901 again. Use 6901. There we go. Well, let's put an annotation here. Right click, brings up the window. And what can we do? Unsure of how to appropriately pronounce this network name. Some people say I see okay. Others do not. Apply. Now we can see this red flags showing up. That means there's an annotation there. And as you zoom out, and it obviously stays scale on the screen. And we hover over it, and it shows you a quick view of what the annotation has in it. If you want to look at it, you just got to right click it again, and it'll show up here. Now, in some dense boards, sometimes you want to put an annotation on something that's actually underneath where the flag is. That's fine. You do the right click like we just did now, and then you just add new. This is another annotation that isn't the same as the first. Apply. And now we can see we've got the two flags, and as you zoom out, they obviously separate out. Okay, so let's show a bit more of this info panel here. One thing to notice, if you click on ground or the unconnected pins, it won't really do anything. The reason being is that there's just so many ground pins and unconnected pins that it would simply overload the system, and there isn't really a lot of point to it. But if we say have a look at, let's trace the SMC, BC, ACO, KVCC. Let me see, we've got three parts on this network. Now you notice here that the pin circles are larger than what they really should be on the pin part, but that's deliberate so that it covers the area needed to show the text. We had it before where the pins went enlarged when zoomed out, and it just made things impossible to read. So as we zoom in, they pick up normally again. The green halo is just there to make things a bit clearer that that is what you're hovering over. Alright, so we've got three parts here, and let's see, where'd they go off to? What's this? We got a test point there, and what have we got under here? Alright, the U6900, what's this one, Y? Now if you want to jump to other networks, that's fine. You just simply pick any of these networks that you want. So that was this one, and it now changes over to that, picks up everything that's on there. We go back to ACO, okay. So I find the info panel to be a lot more useful for tracing through boards, trying to track down faults. It also gives you an insight of what's connected to the same parts really quickly without having to refer back to the schematic all the time. Okay, what I'm going to do now is load up a FZ file and demonstrate that there's a few extra features in the FZ files that we're putting in. So this is a micro ITX board, and with the, let's see if I can find one, there we go. You'll notice now that there's actually part information referring to what we've clicked on here. And we've got here connector, 4-pin, 1mm pitch, right angle, surface mount, which is useful if you're trying to find out what something has and you don't have the schematic with you. Some of the parts will actually have their values as well. Oh, here we go. Yep, resistor 0 ohm, 1/16 A402 size. So hopefully eventually we'll get more board formats that actually include this information as a general rule, but I don't expect that coming out of Apple anytime soon. Okay, well, I think that covers everything for now, and I've gone on long enough. hopefully you'll find some use with the OpenFlex board view. Hopefully it makes debugging boards a lot easier for you all. Certainly it's been an interesting process writing these extensions. It was supposed to be a 3-day project and it's turned into a 4. Anyone else who's written software will know that's pretty normal for how these things go. So if you've got any questions or you simply got ideas, certainly send me a message. My contact details are on the OpenBoardView.org website, and if you want to help debugging or any coding, things like that, just come along to the GitHub repository that we have there. We do have the OpenBoardView organization, which has myself, Chlorodite, and a couple of other developers who are doing a lot of good work. Peronov did a lot of the Linux porting work, which is very essential to where we have it now. I should point out OpenBoardView and OpenFlex do work under Windows, Linux and OS X, so it's quite portable, which makes it good for everybody. Okay, well, I'll leave it at that before I waffle on too much more. Thank you very much for listening, and hopefully I'll put up another video later. See ya.